Assalamu alaikum all of you. Welcome to one more session for data transmission. Today we are going to discuss about the error checking methods. Now what are the error checking methods and how does then error occur while you are transmitting the data? So while we are transmitting the data from one end to another end, now it might be from the sender's end to the receiver's end or from the receiver's end to the sender's end. So there is a corruption of the data due to interference. Now the interference could be due to the hackers, it could be due to the cracking or due to any signal disturbance or the noise distortion. Then the second thing, what do we have? We do have a problem during this packet switching. Packet switching we'll be learning in detail afterwards, so I'm not going to highlight this thing over here. And the last thing is the skewing of data. Now what do you mean by skewing of data? The skewing of data means that the data is not synchronized properly. For an example, I do say that I have transmitted data in this format 1 2 3 4 5. Now the content of the data is same when it receives this receiver, but it received in this particular manner. That is the thing, that data when it has received in this particular manner, so it's not synchronized properly. This is known as the skewing of data. Now we do have multiple aspects through which we can know that whether the data has been transmitted correctly or not, and then when it hasn't been transmitted correctly, so we need to correct that data. So there are multiple ways through which or by which we can correct our data. So these methods are actually known as error checking methods. Now for the error checking methods, what are we going to do? We are going to study about 6 of them. That it's a parity check, then we do have a parity block, then a checksum, then a check digit, then an ARQ, and finally we do have a echo check. Now first of all, coming towards the ARQ. ARQ says automatic repeat request. Now what does that mean? It means when you're sending the data from the sender's end to the receiver's end. So if the data has reached the receiver correctly, so receiver will be itself asking for the next set of the data. Next set of the data by its own, yeah, but in the given time interval. Like for example, let's suppose I might write over here time interval. Like for example, the time interval was set by the network administrator, that was 10 milliseconds. That means within the 10 milliseconds, receiver should be asking for the next set of the data from the sender. If the receiver is asking for the next set of the data on its own from the sender within the 10 milliseconds that was set by the network administrator, that means the previous data has been received by the receiver perfectly. But if not, there is an error, there is something like that, so, or there is a distortion or there is a disturbance, so receiver won't be asking for the next set of the data. That means your data has been corrupted and now you need to send the entire data once again. Coming towards the echo check. Now when it comes to the real world, so echo is something that you just shout out loud, and just after that you are going to hear your similar voice once again. So similarly, in an echo check, what do we do? The sender is sending the data to the receiver. Now the receiver sends the copy of that similar data that it has received back to the sender. Like for example, data 1 and copy of data 1 that is received by the receiver is sent back to the sender. Now at the sender's end, both of the data, the copy of the data 1 and the data 1 that it has sent to the receiver, both of the data will be compared, and if the comparison is true, that means there is no error while transmitting the data. But if there is it's not equal, the comparison is not true, that means there is an error while the transmission of the data. Yeah, but it's not too perfect, or you may say it's not too good, because it's time consuming in a particular manner, that if there is an error, so you need to repeat the entire cycle once again, you need to repeat the entire process once again, so it's quite time consuming. Coming towards the next transmission error or the error methods, that is known as the checksum. Okay, now checksum is calculated from the block of the data. Now what do you mean with the block of data? Block of data means multiple bytes. Now the block of the data means multiple bytes. So checksum is calculated from the block of the data by an algorithm that is agreed between the sender and the receiver. Okay, now we get a value from that agreed algorithm, and that value is known as the checksum. That value is sent along with the block of the data towards the receiver. Now you can see, you might see over here, in checksum data is sent in a form of a block along with the additional value called the checksum. Process of the checksum is follows. So they are saying, first of all, checksum is calculated from the block of the data before being transmitted. Calculation is done upon agreed algorithm between the sender and the receiver. Okay, then it says checksum is transmitted with the block of the data. Okay, now till here we are right. Now checksum is recalculated. For example, the calculated checksum was for example 161. Now checksum is recalculated once again at the receiver's end with the similar algorithm that was agreed between the sender and the receiver. Now if this value is similar to the value that was calculated earlier, that means your data has been transmitted correctly. But if not, that means there is an error while the transmission of the data. So if both checksum sender and receivers are same, that means is no error, otherwise there is an error over here. So this is how a checksum works. So this is how your checksum is actually working out, or you may call that checksum checks the error in this particular manner. Coming to the next part, that is regarding a check digit. Now when it comes to the check digit, so do remember that check digit is mostly applied over an ISBN number. You may call it as the barcode as well. It is applied over the barcodes, and the last digit in the barcode, or you may say from the right hand side the last digit, and from the left hand side the first digit of the barcode is known as a check digit. It's an extra digit that is utilized to check it out whether the data that has been transmitted is correct or not. Now what are the errors checksum can check? Incorrect digit entered, transportation error. Now what is the transportation error? Transportation error means 1 2 3 4 5. This data should be transmitted, and now it is 1 3 4 2 5. So this is known as the transportation error because the values have changed their locations. Omitted or extra digit, that means 13 digits needs to be transmitted, but the 12 have been transmitted, or you may say 14 have been transmitted. So similarly, phonetic errors, 13 or 30 may sound perfectly same. So this, you may say this is a phonetic error over here. Okay, now how the check digit is agreed upon, or you may say how the check digit find out. So for the check digit, what we actually do, for example, the values are given to us 4 5 6 7 2. Now each of the value is multiplied by its digit position. Each value is multiplied by its digit position. For example, 4 5 20, 5 4 20 once again, 18, 14, and a 2. Now all the values are added together. So it gives you 60 and a 74. Now 74. Now this 74 will be divided by 11 if the question is regarding a modulo 11. But if the question is regarding a modulo 10, so it will be divided by 10. So right now we are taking it by 11. So 11 6 is 66. That means the remainder is 8 over here. Now what you need to do, if the remainder was 0 for an example, might be there is 77 for an example. So 11 7 is 77, remainder is 0. That means check digit is 0. Okay, but if, or you may say if 0, so you may say that check digit is fine. But if you're finding a check digit, so now what you need to do, 8, so you need to subtract this remainder from 11, and you will be getting whatever the value you are getting, that is the check digit over here. So this is how you find out the check digit within the given block of the data. Two common methods of generating the check digit is the modulo 11 as we just did, and the ISBN 13 method that we can do later on, or you may do it from the book as well. Coming towards the parity check and a parity block. Okay, now when it comes to the parity check, so parity check is applied over a byte of a data. Now when we apply it over the byte of the data, what are we actually doing? We are checking out that the parity, is it odd or is it even? Do remember there are two types of the parity, the odd parity and an even parity. Odd parity is represented by a 1, whereas the even parity is represented by a 0. Now, how do we know that is it an odd parity or is it an even parity? So the odd or even parity is calculated by counting the number of the ones in the transmitted byte. Do remember, you do not need to focus on the zeros over there, you just need to focus on the ones over there. So on the transmitted byte, what are the number of the ones that has been transmitted? You just need to count the number of the ones and need to check it out. Now, the first bit from the left hand side, sorry, from the right hand side, or the last bit from the left hand side is known as the parity bit. These bits, or sorry, not these bits, this bit is also known as the sign bit. It may be also known as the HSB, the highest significant bit. Now this bit is having a 0, that means there should be even number of the ones in this transmitted byte. So 1, 2, 3 and a 4. So this means the parity is fine. But if there might be 1, so this is wrong because there are even number of the ones. So make sure you need to check it out that whether the parity is 0. If it's 0, that means the number of the ones, only the number of the ones should be even. If it is a 1, that means the number of the ones in the transmitted byte should be odd. Make sure for this thing. So this is how you are going to check with a parity check, and do remember parity check is applied over a byte of the data. When it comes to the parity block, so we need to do the similar stuff as we are doing with the parity check, but do remember that when it comes to the parity block, so over here block of the data is applied. Now what is a block of data? Block of data means multiple bytes. Block of data means multiple bytes are transmitted simultaneously. So we need to check it out whether all the bytes are transmitted perfectly or not. Now how are we going to check that out? We are going to check that out in this particular manner. Now just have an example over here. Okay, this one is more perfect. Okay, now checking out on the first byte number 1. So the parity over here is 1, that means the number of the ones should be odd over here. Now we are going to check for the first row starting from bit number 2 till bit number 8. Do remember you do not need to count the parity bit. So it's starting from at this place 1, 2, 3, 4, 5. Okay, as the parity was odd, that means the number of the ones should be odd in this transmitted byte. So starting from bit 2 till bit number 8, we are having 5 ones, that means it is fine. Coming to byte number 2, again we do have a odd parity, that means the number of the ones should be odd. So 1, 2, 3, this one is fine as well. Fine. Byte number 3, 0, that means the number of the ones should be even. 1, 2, 3, 4, 5 and a 6. Sorry, I missed one. That means that's fine as well. Now coming to byte number 4. Okay, for the byte number 4, what do we have? We do have a 1, that means a odd parity. So we do have only one single one, or one 1, so that is an that's fine as well. Coming to byte number 5, 0, that means it's an even parity. So 1, 2, 3, 4, this one is fine as well. Coming to byte number 6, odd parity, 1, okay, single one once again. Byte number 7, 1, so 1, 2, 3, 4, 5, that's fine as well. Coming to byte number 8, it's a 0 over here, that means even number of the ones. So 1, 2, 3, oh, that's wrong. So if that is wrong, what are you going to do? You are going to simply highlight this byte. You are simply going to highlight this byte. So I just simply highlighted this byte. Now coming to the rest, byte number 9, 0, that means the number of the one should be even. 1, 2, perfect. Parity byte, the number of the one should be odd. 1, 2, 3. Okay, that's fine. That means only byte number 8 is wrong, otherwise all are perfectly fine. Now we did this thing in the row wise format. We need to do the similar stuff in the column wise format as well. So how are we going to do that? We are going to do that from in the descending order, that means from the bottom to the top. So number of the ones, parity bit is 1, that means number of the ones should be odd. So 1, 2, 3, 4, 1, 2, 3, 4 and 5, that means it's fine. Again 1, so 1, 2, 3, that means it's fine as well. 0, that means even. 1, 2, 3, 4, perfect. Odd should be there. 1, 2, 3, 4, 5, that means it's fine as well. Coming to bit number 5, that's a 0, that means even number of ones. 1, 2, 3, 4, 5. Okay, that means there is an error over here. So what are we going to do? We are going to highlight this one. Alright, so it has been highlighted now. Okay, rest we are going to check it out. 0. Okay, now for 0, what do we have? We should be having odd number of the even number of the ones. So 1, 2, 3, 4, fine. 0, even number of the ones. 1, 2, 3, 4, 5, 6, fine. Again, now odd number of the ones. 1, 2, 3. Okay, so this is fine. Now where did we find an error? We find an error on bit number 5 of byte number 8. So the next question the examiner do says that how are we going to correct that error? So we do say by reversing the value of bit 5 of byte 8. You may write it down in this manner as well, or you may say by reversing the value of intercepted cell. If there are multiple errors, so you may say by reversing all the values of all the intercepted cells. So this is how a parity block works. So this was all for today. Thank you so much. We will be continuing further in the next session. Allah Hafiz.